Welcome to Module 3's Python lesson. I'm Professor Seth Frey, and today we're going to learn about the different kinds of things that Python has. To date, we've learned that Python is useful as a calculator. We've learned how to manipulate and work with numbers and reproduce a lot of what we learned in algebra back in the day. We learned about variables, how to store information in them and change them over time and have them work together to build bigger aggregations of meaning. And we learned about modules that let you pull in extra functionality from outside of the base Python that do increasingly fancy and useful things. Nice code written by other people that we can pull in and use to advance our own goals. From that foundation, we're going to dig into the following objectives. We're going to discover more types of data beyond numbers. We're going to learn how text is represented in Python. We're going to learn a little bit more about how to handle errors, what to do when we get one. And we're going to learn how to, once we have this collection of different kinds of things, we'll learn how to compare them. As usual, you're going to run your boilerplate code, and from there, we're going to start on error messages, things we can do about them when we encounter them, and their different kinds. So I'm going to start just by typing, I'm going to be polite. I'm going to treat Python like any other person. I'm going to say hi. Greetings, Python. Lovely weather today. I'll run that to sort of say hi, to be polite, to be a nice, normal person. And I get this very rude response. So Python's not talking like a person. It's not speaking human language. And that's a lot of the reason that we write code to speak computer language, because we can't count on Python to speak human language. We can't even count on it to say in a reasonable, we can't expect it to say, oh, come again? No, we just sort of get this very blunt failure of the code to run. We get error messages in Python, even though we didn't get them in your calculator. Why is that? It's because Python's more powerful. It's more complicated. It can take a wider range of inputs, which also means more can go wrong, and it's more likely to encounter something it doesn't know what to do with. Calculator only has so many buttons, and every single one of those buttons has an appropriate use at every time. But in Python, that's not the case, and so we get error messages. This is what they are, is the language telling us that it didn't know how to handle what just happened. And it tries to give us hints. In the case of greetings, Python, lovely weather today, what it's telling us is invalid syntax. Which is to say, maybe the words were okay there, but there was something wrong with their relationship. There are several things to do when you get an error message like this. As you get better, you'll sort of get in the habit of copying the error message and Googling it. And in this case, we see lots and lots and lots of syntax error. Plenty of hits for that. You're not alone. If this is the first time it's happened to you, it's happened to lots of other people before you. But short of that, while you're really getting started, the most common thing you're going to do is ask for help. I've prepared a resource sheet that sort of gives you steps to follow when you encounter an error. I'll start you off Googling it. I'll have you, refer to the notebook and go through the notebook, go through my commentary, and see if you get any hints there. You might have a class. After that, that's when you start reaching out for people. You can tell another person, I've done my due diligence, I looked around, I wasn't able to solve it on my own, please help me, I have no idea what to do. You start with your classmates. You can start with non-class friends who can code. You might be buying them lots of coffee. And as you climb the ladder, you can start reaching out to TAs, you can start reaching out to me. In the broader community, there is something called a PUG, a Python users group. Davis has one. It meets on campus. And that's another excellent resource as you dive into learning this particular programming language. I also have some reassuring things to know that you want to know. So those are the main strategies for how to face an error. And I've said before, you sort of can't know any of it till you've learned all of it. Errors are going to be inevitable. Your relationship with them is going to evolve. In the case of this particular problem, there's several ways we can solve it. One way we can solve the problem of this error, of this code producing an error, is delete it. Then nothing happens, we don't get an error. And that's a fine strategy, especially if you want to submit this notebook in a way that doesn't produce any errors, which is a requirement for getting full credit. Other ways to fix it. The simplest thing you could have done is wrap it in quotes. By wrapping in quotes, we represent this text as the kind of text that Python knows how to read, called a string, which we're going to learn more about. Another option you can do is comments. You can comment the code out. It really depends what you meant or what you wanted to happen when you typed the thing that produced an error. Were you really talking to Python? Were you writing a note to yourself? Were you trying to define some text that you want to manipulate? And these are all options that you're going to become more comfortable with, and directions you're going to become more familiar with respect to whatever your goal is. The anatomy of the error message is useful to have just a basic passing understanding of. It tends to have three parts: where the error occurred, specifically a printout of the line that had the error, and then what kind of error you had, what the error was. This first line, most of it's not useful, except you do get what line the error occurred on in your code block. Did it occur on line 1 or 10 or 20? That helps you find it a lot quicker. You just count the lines until you find specifically where Python had a problem. In the second line, it'll actually tell you, it'll print out the line it had a problem with. And the error, your problem, as you get more experience, might just pop out at you, and you'll be able to get through that error very quickly. Then below that, we have Python's message to you about the problem it encountered. So we have up here where something went wrong, and we have down here what went wrong. This is called a traceback. That's just jargon. There's lots of kinds of errors in Python, and that's why it's going to be a good practice to copy the specific error you got, paste it, read a couple web pages that describe different people encountering that error in different contexts, and you'll eventually get more and more and more of a picture of what caused that error and what you specifically did to cause that error. So I'm giving you errors in kind of controlled way. I'm telling you, take this code that doesn't work, type it out, look, it doesn't work. But a lot of the errors you're going to get aren't like that. It's nice to get controlled errors because they're well contained. Be sure to delete them. Be sure that you don't still have that error being produced when you submit your code notebook. With that introduction to errors, we can now get into more of real Python. What are the types of data in Python? There is a function, we learned about the function print before. Print takes something and shows it to us. Type takes something and says what kind of thing that is. So we've played a lot with numbers. What type of thing is a number? Well, there's different kinds of number. This number is an int, it's short for integer. This number is a float. That's not short for anything. 1 and 1.0, they're the same number, but Python understands them as different kinds of things. It represents differently integer numbers and numbers with decimal points. It does that because of the challenge computers have dealing with numbers that aren't integers, which we'll find when we divide 2 by 3, and instead of getting 2/3, we get some infinite number or seemingly infinite number that stops. We get 0.66666 on and on and on and on and on, as far as it can go, which is about 15 digits, and then it stops. That's not really the right answer, but it's close enough to the right answer that we're content with it. But it's just important to know the computer literally can't represent 2/3 as a decimal number. It just breaks down. And so floats are the computer's best shot at representing a continuous number. What's the type of 3 plus 5? Well, the type of 3 is int. is another integer. There's no decimal point. Type of 5 is integer. So presumably their sum is also an integer. And that's what we're going to find, int, right here. If we were to add 3 to 5.0, it could go either way. It turns out it goes float. The result ends up being 8.0, a continuous or decimal number. Now, what's the type of greetings Python lovely weather today? That's a str, short for string. String. Why is text called string? Python understands text as a bunch of characters, a string of characters, a bunch of characters in a row that produces text, which, again, we're going to get to. We're going to see more of. So the first new type we're going to dive into is the idea of truth. The idea that some things can be true, some statements can be true, and some can be false. So true is a thing in Python. We know that because when I type hello, the text is black, 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 black. The text is always black. When I type true with a capital T, it's black, black, black. As soon as I type the E, it becomes green. So Python is saying, I recognize that as a thing that I recognize. When I run true, what do I get? True is true. True is true. What type of thing is true? It's called a bool. That's short for Boolean because this is going to sound funny, but there's a guy named Boole who invented the idea of true and false. And so they're named after him. False is false. False is another type of bool. There's only two. There's all kinds of strings. There's all kinds of integers and floats, but there's only two kinds of booleans. There's true, and there's false. We have this word called not that negates things. So not true is false. Not takes whatever's in front of it and negates it. So in this case, I have true, I want to negate it, so I'm going to type false, and that's what the value ends up being. I take false, I negate it, I get true, and so not false is going to evaluate to true. We can do double negatives, not true. What's going to happen here? Well, not true is false. Not false is true. So Python's going to evaluate parts of it and turn them into something it recognizes and keep doing that until only primitives are left. Only these really basic things are left. There's plenty to do to play with basic Booleans. Make sure you understand Booleans and we'll move along. Having learned about true and false and their basic representation in Python, it's just the idea that they are directly represented in Python. Now we're going to get into text and strings. We're going to be able to start to work with text in Python. So text is represented as strings of characters. So let's start with characters. We'll take something and put it in quotes, and Python will understand it. Each of these is a single character. A and B and C. The whole alphabet's a single character. Anything else we put in quotes is a character. A space in quotes is a character. And of course, as I type more things, I get longer and longer characters. So space here is a character. Number is a character. Everything in the parentheses, everything in the quotes is a character. Just as integers have a type, strings also have a type. The type of 1 is an integer, but the type of quote 1 is a string, str. So quote 1 and 1 are different things. They look the same, but one's the string representation of 1 and the other is the number representation of 1, and those are different things. We'll give you some practice writing strings out, and then we'll move along. So strings have length. So the length of hello is the number of characters composed of it. In this case, 5. If I were to put a space, space is a character. So I compute that and I get 6. The length is 6. It includes the space character. If I were to delete everything but the space, what would the length be? Well, space is a character. So the length of this should be 1. Moving along, we can assign strings to variables just like we assign anything to variable. So, I can never say it. This is a type of fish. The length of that string is going to be name length, and then we can combine. We can print several things. So what we're going to do is we're going to print out a bunch of things. We'll print out the name of the fish. We'll print out the string is a Hawaiian fish whose name is. Then we're going to print out this number, the length. Then we're going to print out the phrase characters long. What we'll get when we glue all those two things is a sentence that we just sort of created. This is a Hawaiian fish whose name is 21 characters long. To quotes. So I introduced you to single quotes. You can also use double quotes. It's kind of the same thing. It's going to come out the same thing. So why does this matter? Why is it different? Well, sometimes you're going to want to use a single quote or a double quote in your string, and that's confusing. If I was to write, you can already see the red. Python thinks I is my string. It thinks my string ended because I used a single quote. I'm a happy camper. And if I run this, I'm going to get an error. Oh my goodness. Not just that, but it's just having a lot of trouble parsing and understanding what I'm trying to say. This is going to get an error. And that's really why double quotes exist, so that I can use single quotes. I can use a single quote in my string. Oh, what a pain. What a pain. It's trying to help me out, and it's just causing more trouble. And giving me two quotes when I only want one. Okay, that no error got produced. Now I might want to say, let's say, the opposite can happen. Single quotes are useful when I want to use double quotes in a quote. So, she says, hi. That will run without an error, but if I tried to wrap the whole thing in double quotes, I would have gotten an error. Error. Okay. So back to single quotes. So single quotes are nice when I want to use double quotes. Double quotes are nice when I want to use single quotes. If you have some text that you really want to use both, there's ways around that too. We might get to it, or you can ask. The real name of that fish actually does have a single apostrophe, so the best way to represent that name is with double quotes around the string rather than single quotes. Now, if you want to represent really long text, then you should use three quotes. Three quotes make it so that you can use single quotes and you can use double quotes. Where's my double quote in here? Oh yeah, there's my single quote. There's my double quote. You can use all kinds of stuff. It's very rare in text that you're going to have three double quotes or three single quotes in a row, and that's why you can kind of get away with this. I'm eating, it's. And I run that, and that's just a string. If I were to type it into type, I'm going to get a string. It's the same kind of thing as we've encountered before. It's just there's lots of ways to represent strings because of these little details. Little details that you're not used to paying attention to, but the computer is very important to the computer to pay attention to these details. And that's what it means to think like a computer. So try this out. Make sure you understand the different kinds of quotes, and we'll move along. So having learned how to create strings, we now want to know how to sort of look in them and use them and see their parts. We can do that with the command in. So let's take this one line at a time. This first line is asking, is capital H in the string hello? I think it is. It looks like it is. Is lowercase h in the string hello? It looks like it isn't. Is X, capital X, in the string hello? It looks like it isn't. So what I'm going to expect, in is sort of a question. It's literally, is H in hello? Is X in hello? And we should get back true or false. Let's see what we get. I'm expecting 1 true and 2 falses. And that's what we get. 1 true, 2 falses. Is the substring, I'm going to call it a string, the string bad word, is it in this bigger string? Ironic is a bad word for incongruous. It is. Bad word exists right here. This string of 8 characters is a part of that bigger string of more characters. Right there. Now let's see. Now we're asking, is the double quote character in the string say hello? Then we're asking, is the single quote character, and nothing else, it's just the single quote character in the string say hello in here. I think the double quote character is and the single quote character is not. Let's try it out. So I get a true and a false. That's great. We can do this for lots of other things. We can also try not in. Is it true? Is it the case that A is not in A, B, C, D, E? A is in the A, B, C, D, E, so that should be false. Is it true that there's no I in team? That's true. Is it true that there's no crying in baseball? That's true. So I got false, true, true. Is there any crying in crying ball? There is. The string crying is in the string crying ball. So that should come out true. Is there any in crying ball? Yeah, there it is right there. I-N, right there. So this should evaluate to true. This can get really, there's some details to pay attention to. We can ask the question, well, is hello in the string hello? Well, here are the letters hello, and do they exist somewhere in here? They do. So hello is in hello. This seems like an alternate way of just asking, is hello equal to hello? But there are times that in is going to return true when equals does not. In this case, hello is in hello, but hello is not equal to hello. So that should return false, and it does. So equals and in, they can sometimes replace each other, but they are different things. This goes all the way down to single characters. The single character I is in the string of the single character I. True. So try your string comparison out, your substrings out, and we'll move along. So having learned how to look inside strings, now we're going to learn how to combine them in useful ways. We got a little hint of this when we did print, and we put several things separated by commas. So I have the name Deb, I have hello, I have name. When I run this, I should get one string that says, hello Deb. Hello Deb. There we are. If I assign the number 60 to the variable answer, I can say the correct answer is, comma, answer should be 60. And I'm going to get the correct answer is 60. So I took one string, I took another string in this case, and I got a bigger string. In this case was a little more nuanced. I took a string and I took a number, and the number kind of got turned into a string through some magic. Because Python was being nice and holding our hands that once. It doesn't always do that. There's lots and lots of syntax. Combining strings is a common thing to do, so there's lots of syntax for doing it. This is a slightly more complex one that you're going to learn to love. It'll really grow on you. What we have here is hello space and then 2 angle brackets. I don't know. It's some syntax. And what it's saying is angle brackets is like a placeholder. Then we have this. This is just a lot of syntax. You have to file this in the part of your brain that's, I'm just taking this on faith. I'm just memorizing this. It doesn't totally make sense. It's not going to make sense for a long time, but it's my job to remember it and to know it, because a lot of learning a code is just sort of memorizing arbitrary things, kind of like all of biology. So this is your placeholder. Then you close your quote. So this is your string, hello, and then space placeholder. Then we do dot format. We follow the string with dot format, and then we have these open parentheses. Then we have our variable deb. What's going to happen is whatever's in the parentheses is going to go in place of the placeholder. So when I run this, I'm going to get what I got above, hello deb. Same thing here. The correct answer is open close. Dot format answer. So answer should go in the placeholder. The correct answer is 60. And here we have a third example. Name is Deb. Answer is 60. Because I have two things separated by a comma inside the format, I'm going to fill my placeholders in order. I have two placeholders, one curly bracket there, one curly bracket there. The first one's going to get filled with name. The second one's going to get filled with with answer. So what I should get is Deb. I should get something like this. Deb is 60 years old. Python's just going to replace the curly brackets with the value of the variable. So let's try it. Deb is 60 years old. Wonderful. There are other ways to do it. You can literally use addition on strings. So hello plus space plus world will give us the string hello world. Comma multiplied by 3 plus chameleon will give us comma, 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 chameleon. You can multiply a string several times. Now, what would have happened with hello world if we hadn't added the space? Well, if we hadn't added the space, we wouldn't have gotten it. That hello world would get all crammed together into one word. Same here. Look how we ended the comma with a space. If we get rid of the space, all those commas are going to get crammed together. We won't have any spaces. We have here in the output, comma space, comma space, comma space, chameleon. I got rid of the space. We run it, and everything's crammed together. So space is a character that you kind of have to not forget about. So that's a third way of combining strings. One's within print using commas, one's with this format thing, the other is just using addition to combine strings. So there's a lot of ways to do it. I'm going to recommend the format one. It sort of has the fewest headaches. I'm not proving that right now. You kind of have to take my word for it. It certainly makes it easier to think about. The hardest to think about in terms of the one that you're most likely to make space mistakes, where you don't get spaces where you wanted them and you have to think about that, is this plus syntax. It's convenient. I'd sort of avoid it. Hello world's all crammed together. If you do want to do the plus thing, there's lots of places you could put the space. I put it before as a separate character between hello and world, but you could put it at the end of hello, or at the beginning of world, or if you do it this way, you do both, you'll get two spaces at the end. So that's hello, space, space, world. Why are we talking about spaces? This seems sort of small and insignificant, but that's a lot of thinking in code, is learning to think like a computer, learning to handle these small, insignificant details, learning how to not see them as important exactly, but remember that they're there. Keep them in mind. Always have a separate part of your brain. There's you, and then there's you simulating a computer. And developing that part of you is very powerful. It makes you a more powerful thinker. So these minutiae end up being something you get in the habit of being able to keep, and that's great. That's great for your thinking, for your attention to detail, and for your learning to build things in code. So having learned how to create this thing and that thing, it's useful to be able to compare two things to each other. And we're going to use equals equals, and we'll also learn about exclamation point equals, which is going to be not equals. Equals equals is different than equals. We used equals to assign variables. Equals equals is a different thing. 0 equals equals 0 is a true statement. 0 equals 0. Yes, it does. 0 equals equals 1 is a false statement. 0 and 1 are not the same thing. When I run this, I should get true and false. True and false. 1 is not equal to negative 1. 0 equal to negative 0. Boy, is 0 equal to negative 0? What is negative 0? It seems to me like 0. So I'm going to guess that the first is false, the second is true. And yeah, I get that. So it turns out 0 is equal to negative 0. Not every programming languages sort of accidentally end up with this idea of negative 0, which isn't a thing in math, but it is a thing in programming. You'll never encounter it, but it's I'm sort of showing you a little bit under the curtain the nuances, the failures of a computer to represent mathematics because it's a machine. because of its own shortcomings. Having learned equals equals, we learn about not equals. Is it the case that 0 is not equal to 1? It's true that 0 is not equal to 1, so we should get true. 0 is not equal to 1. 2 plus 2 is not equal to 5. That sounds true to me. 4 is not equal to 5. That sounds true. Is 4 not equal to 4? Well, 4 is equal to 4. So 4 is not equal to 4. This is a false statement. Is false equal to false? Yeah, false and false, they're the same thing. So that should be true. It's true that false is false. We can compare strings as well. The lowercase a is equal to lowercase a. Lowercase a is not equal to uppercase a. Those are different characters. Those are different strings. So we should get true and false. True and false. I'm giving you the ground rules, and these are a lot of things that if you feel like a lot of this stuff, if you're comfortable just memorizing, if you feel like you don't get it and you're comfortable just memorizing, memorize. If you feel like you need to get it, you're going to have to just sort of float around for a while, and eventually exposure and practice is going to make you all get it. And if you're just getting this right away and I'm going way too slow, well, that's great. That's great. You're getting it. So as I said, equals equals is different than equals. Equals equals is comparison that returns true or false. Single equals is assignment. It takes there's one thing on one side of your equal sign. There's another thing on your other side of your equal sign, and it takes a value and creates a variable. So variable equals 1 assigns the value of 1 to a variable called variable. Variable equals 1 then asks you, this variable I just created, is it equal to 1? I'm going to give you a little practice distinguishing comparison and assignment. Having tested for exact equality, there are a couple other tests we can run. In addition to asking equal to and not equal to, we can ask less than, greater than, less than or equal to, greater than or equal to. And these all sort of make sense the way you'd expect them to from high school math. 4 is less than 5, true. 9 is greater than 1, true. 4 is not less than 4, but it's equal to 4. 4 is not greater than 4, but it's equal to 4. So these are both equal to true. And these other comparisons, yes, 1's greater than 0. No, 2's not greater than 3 or equal to 3. Yes, 2 is greater than or equal to 2 because it's equal to 2. Yes, minus 1 is less than 0. Yes, 0.5 is less than 1. And what type of thing is 0.5 less than 1? Well, when Python sees this, it's just going to replace that with true. What type is true? True is a Boolean. So that's what we should get. In summary, all of these were true except the second one is false. So I should get all trues. At the very end, I'm going to get Boolean. Why did I cram all those together? Why didn't I go one by one? We're chaining commands together. We're expanding our memories. We're improving our ability to read lines of code and sort of go methodically and simulate in our heads without constant feedback. Simulate in our heads what's happening, what's going on in every line, and sort of guessing to make sure that we understand every concept. So try your comparisons out a little bit and we'll move along to the final part of this lesson. We're going to bring it all together. We learned about strings. We learned about true and false. We learned how to compare things. We learned how to combine strings. And how is this useful? Well, it's really useful. It's useful for asking questions about art and beauty and repetition. So it's come up a couple times during this lesson that we have all these minutiae to deal with, that we have to be really precise, that we have to be rational and logical, that there's all this system and structure to pay attention to that we assign with this rigidity that seems really far away from maybe the kind of thing, the way we're used to thinking. Creativity, the open-mindedness, and art and beauty and these big ideas. So our little bringing it together demonstration here is going to show that the line between those big, beautiful, soft ideas and cold, hard rationality, system structure, there's not a line. They're really a lot closer than it seems. A lot of things that we think of as art or that we think of as emotional have very rigid structure built into them. Our case in point is going to be Taylor Swift's Shake It Off. So I have here, using triple quotes, I'm able to take the entire lyrics of Shake It Off and assign it into a variable called Shake It Off Complete. If I print that variable, print Shake It Off Complete, I'll just get a long string in Python. What's the type of that? What's the type of this variable? I should get that's a string. There it is. It's a long string. It's being represented in a variable, the entire text of the song. And what type is it? It's of class string. It's a type string. That's great. So if we look closer at that song, there's a lot of parts that are repeated. We can actually decompose this according to sort of pop music theory. Every pop song, more or less, has a couple verses, a chorus that it keeps coming back to, maybe a bridge for variety, and the anatomy of a song we can actually break down. So in this next block, we have the exact same song, but what I'm doing is, instead of assigning the entire song to one variable, I've divided the song up into its parts. We've got the first verse, verse 1, assigned to a variable called verse 1. We have the second verse, assigned to a variable called pre-chorus, which is part of the chorus. We have the chorus here, we have the second verse, a post-chorus. This is a more complex pop song. It's got a lot more structure, but it is decomposable into parts that we can analyze. We've got the interlude, which is different than the bridge, and all these parts together we can reconstruct Shake It Off. So Shake It Off Reconstructed is a new variable that I'm creating out of those variables I just created. Shake It Off Reconstructed is verse 1 plus pre-chorus plus chorus plus verse 2 plus pre-chorus plus chorus plus post-chorus plus interlude plus bridge plus chorus plus post-chorus times 3. At the end of the song, she repeats, what does she repeat? She shakes it off a lot. And what we get is the exact same song. In fact, we can test the equality of the variable Shake It Off to the variable Shake It Off Reconstructed. What do you think is going to happen? Let me run this code. Is it really that decomposable? Is the song so decomposable that I could represent it as a bunch of variables and get the same thing back? True, they're the same. Down to the letter, you remember how sensitive Python is to spaces. Down to the space, we were able to show that we can decompose Shake It Off into parts. But we're not done. That was the song level structure, but we can now go within a verse and also represent all the repetition within a verse. Choruses tend to be very repetitive, so that's where we're going to pay most of our attention. What do we have in the chorus? We have all this play, 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 play. That's a lot of repetition. Remember our multiplication? We could use our multiplication to compress that. That's just play, 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 play. That's just play times 5. Hate, 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 hate. That's just hate times 5. We can sort of bring it down. And again, by the fact that we can compress this song is a sign that it has regular structure, that it's, in that sense, rational, structured, logical, and decomposable, analyzable. Analysis means that is literally to slice, to cut something up. We're analyzing Taylor Swift. We're slicing it up into tinier bits and revealing that the whole is a very deliberate assembling of the parts. So let's see. Taking the chorus, what I'm going to do is reconstruct the chorus. So remember format? Format we have our curly bracket gobbledygook, and the first curly bracket is going to get filled in by the first thing before commas, which is play times 5. The second curly bracket is going to be replaced by hate times 5. The third by shake times 5. The fourth and the fifth, what's going on there is I shake it off, I shake it off. So I just created a variable here called I shake it off, and I'm going to throw it in twice with a comma and a space in between. Then we're going to break, fake, and shake 5 times, and then we'll shake it off twice again. And all of that was in format. That might look weird that for our format command, all that stuff within parentheses, we're allowed to go across several lines. You're actually allowed to do that. Just like you're allowed to be liberal with spaces, you're allowed to be liberal with new lines where it makes things more readable. And I don't know, maybe I'm wrong, but I sort of thought that adding these new line breaks made this code more readable. It's pretty big code. It's sort of a pretty big leap from this one line here, one line there that we've been doing in the lesson. But that's what I mean by bringing it all together, is we take the next step in complexity to do something useful. So let's run this. Chorus reconstructed. We're going to ask the question, is chorus reconstructed equal to chorus? Was our analysis essentially successful? Was it an accurate reconstruction, an accurate representation of the chorus? Chorus equals chorus is the code I run at the very end of this block, and I get true. We can keep going. The post chorus, that's super repetitive. I shake it off, I shake it off, I shake it off, and so on, and so on, and so on. Here's the compressed version of the post chorus. I have some eyes, but most of it, at this point, most of it is repetition. Most of it is something I'm able to take apart and rationalize, analyze. I can go further. This is sort of becoming more about me than about you, but I'm seeing how much I can compress the post-chorus and make it tinier and tinier and tinier. This is the shortest I was able to get it, is right here. We say shake it off, and then we have 4 parentheses. Each of those parentheses is this variable, then those variables. This variable is the combination of those variables, which is defined up here. What's the idea? Well, we were able to reduce post-chorus to 1/3 of its size. That reduction means that it doesn't mean that a lot of the song doesn't have to be there. No, because repetition is an aspect of the emotionality, because it introduces larger themes and larger units, and we get a sense of many levels of structure of a song. It also improves the memorizability, which aids our ability to connect and feel something and feel a relationship to the song. Which is all to say that logic, rationality, structure, decomposability, analyzability, all these sort of Python-y things are actually completely in service of art and creativity. That's our big takeaway, that if you've never identified as someone who learns the code, well, probably neither is Taylor Swift, but there's still a way of thinking that both have in common, and you can relate to code if you can relate to a pop song. What did we learn? We learned that Python has lots of kinds of things. They have different properties. They can do different things. Specifically, we learned how to represent text, which is a pretty useful thing to be able to do. We learned how to look within a string of text, to grow strings, to shrink strings. We learned a little bit how to handle errors, what to do about them. And we learned how to compare things. These are all building blocks, and we're slowly going to build up more and more complexity until we can do exciting things on our own in Python.